and differentiate as though f is a function of x alone. We call the answer df by dx using this curly d. For example, if f of xy is x squared y squared, then df dx is 2xy squared, because we've differentiated as though y squared is a constant number. And if f of xy is x sine x squared y squared, then using the product rule for differentiation, the partial derivative of f with respect to x is the derivative of x, which is 1, times sine x squared y squared, plus x times the derivative with respect to x of sine x squared y squared, which is 2xy squared cos x squared y squared, which when you put together is sine x squared y squared plus 2x squared y squared cos x squared y squared. Here are some for you to calculate where the answers are given in the yellow panels. Now, to compute higher order partial derivatives, for instance the partial dm plus n of f by dx to the m dy to the n, first differentiate m times with respect to x and then n times with respect to y. For example, if f of xy is x squared y squared, then d3f dx dy squared is d2 by dy squared of df dx, which is d2 by dy squared of 2xy squared, which is d by dy of 4xy, which is just 4x. You'll need to go through this carefully yourself. Here are some for you to verify. Now, the chain rule for partial differentiation is if we have a function of two variables, f is f of x and y, and x and y vary along a path in the xy plane parameterized by a parameter t, then f varies with t via the chain rule. D by dt of f of x and t, y of t is df dx dx dt plus df dy dy dt, where we have to evaluate df dx and df dy at x of t and y of t. So the final answer should all be in terms of t. For example, if f of xy is sine xy squared and x and y vary with the parameter t, x of t is t cubed and y of t is 1 over t, then df dx is y squared cos xy squared, which when we put x is t cubed and y is 1 over t, comes out to 1 over t squared cos t. df dy is 2xy cos xy squared, which if we put x is t cubed and y is 1 over t, we get 2t squared cos t. dx dt is 3t squared and dy dt is minus 1 over t squared. So df dt is df dx dx dt plus df dy dy dt, which is, substituting in from the first panel, 1 over t squared cos t times 3t squared plus 2t squared cos t times minus 1 over t squared, which equals cos t. Here are two for you to try. So, in this learning unit you have practiced partial differentiation and the chain rule for partial differentiation.